Ladies and gentlemen, we're about to begin. Sal, please go ahead.
Thank you. Welcome, everyone. Thanks for joining us today. This is Sal Salamone, Executive Editor at Ziff Davis Enterprise, and welcome to today's web seminar, System Architecture and Capacity Planning Ideas for Big Data in the Enterprise. Obviously, it's a very timely topic with all the interest in big data and with also the interest in keeping costs down and improving performance. Today's event is brought to you by, our sponsor today is Conducive Technologies. Now, many of you may not know who they are, or you may not recognize the name anyway, but they're actually very familiar to most of us. Basically, Diskeeper Corporation changed its name to Conducive Technologies in March of this year, and it's in line with, as they were growing and moving into different areas, their technology has been changing, and it just was a little bit better, to move into this area to have a new name. With that, I wanted to just talk a little bit about today's speakers. We have Howard Butler, who's Senior Director of Systems Engineering and Field Support at Conducive Technologies. Hi, Howard. How are you doing today?
I'm doing quite well. Thank you very much, Sal.
And then we have Mark Weir, who's joining us. And Mark is a system architect and former Assistant Vice President of Enterprise Capacity Planning for Wells Fargo. So Mark brings quite a bit of industry experience and hands-on experience in working in the financial services industry and dealing with big data before it was even called big data. While he was in these roles, he had to obviously take care of handling capacity planning and also keeping an eye on the bottom line. Throughout today's presentation, we'll be joined by these two speakers, and we also want you to chime in. So throughout the presentation, we want this to be very interactive. So at any time you can ask a question. We'll have time at the end for Q&A. So just hit the Q&A button for that. You'll also be able to get a copy of the presentation. So if you would rather listen rather than take lots of notes as slides appear, you'll have the presentation available in PDF format after the event. Additionally, if you want to share any of this through your social networking sites, we have tools built right into the console. We have widgets for the major sites where you don't need to leave the console to send a message out. And if you do that, we have a hashtag if you want to use it. It's #Conducive. Throughout the presentation, as I mentioned, we encourage you to ask questions. And then at the end, we'll have the time for the Q&A. Now, just to go over a bit of what today's agenda is, we'll start with a brief introduction to the topic. We'll then talk about some of the new thinking that's required with big data. And we'll get through a couple of steps that you should take, stages you should go through in enterprise capacity management, sort of looking at a logical flow of how you should address this. And then at the end, we'll wrap up with some recommendations on strategies and approaches to take, and we'll follow that with the Q&A session. Now, before we want to just start bringing in Howard, if you could join us. How are you doing?
I'm doing well.
So
Thank you very much.
Thanks for joining us. I was wondering if you could tell us something about, really to kick us off, talk a little bit about big data and how it impacts system capacity planning.
Sure. Thank you very much, Sal. Big data takes on many forms and is most often used to gain a competitive business advantage. And as industry analysts have stated, the amount of data that is generated and collected and analyzed is really exploding beyond belief. And companies are capturing trillions of bytes of information about their customers, their suppliers, internal operations, and so forth. And when you add to this the unprecedented growth and adoption of personal mobile devices and social media sites into the corporate world, it's generally going to be expected to continue to fuel this growth in an exponential way. Big data, which is really just large pools of information that can be captured and analyzed and communicated throughout an organization, really is now part of every sector and function of the global economy. And this truly changes the way we must look at and plan enterprise capacity management. In fact, the CIO can no longer make intelligent business decisions without looking at and comparing the impact of application and system behavior when analyzing their needs and feeding it back into their business plan. Therefore, collecting and understanding the hidden treasures of computer resource utilization is another facet in of itself of big data and provides insightful information, which are the underpinnings of predictability, productivity, and planning for the enterprise capacity management thought. And in the next few slides, my colleague Mark and I will walk you through some of the ideas and stages of a new way of thinking. Mark?
Thanks, Howard. Enterprise capacity management. Why does it matter? Let's say a supersized retailer tracks historical customer purchasing habits in order to anticipate how the market will respond to new products, promotions, and competitive pricing. Transactional data is summarized, analyzed, and stored. And additionally, we'd likely have warehouse inventories and sales tracking across multiple regions. Together, this data is stored relative to other market analysis data in order to gain insight into consumer behavior. What are our competitor influences? What medium was used in the sale? Mobile, browser, or were they in a physical store? Did social media play a role? Who shopped but never purchased? Over time, the data has become a valued but unwieldy resource to the business in attempts to maintain market share and realize new markets. Meanwhile, back at the data center, how much data should be kept? Where should it be kept? How is data relevance determined? What impact does a promotion on the consumption of IT have on the consumption of IT resources? More specifically, how does the business plan translate to systems demand? And while we're at it, in the dynamic nature of retailing, how do we keep our systems plans relevant to supply business demand? This is the scenario that speaks to the need for enterprise capacity management. Enterprise capacity management aims to support business goals and objectives while managing cost, risk, and quality of service. Fundamental objectives are the catalyst for the capacity management and planning activities that have historically been the focus of infrastructure technology groups. Obviously, technology groups aren't going away, but consider a broader perspective, one which takes into account complete service management lifecycle. That is, all of the things that have to take place from a resource management perspective to keep both the business and its customers happy. I believe we have a poll.
Yes. So before we move on, we thought we wanted to engage you guys in the audience, and we have a question. Are you using? Can we push the poll out? There we go. Are you using ITIL service management for capacity management? You have four choices. Just pick the best one that applies. That you have implemented ITIL service management. You're considering implementing it. You're not considering it, or you're not familiar with it. And we'll give people a few seconds here to cast their votes. And while we're doing that, I just do want to remind people to send in questions throughout the presentation by hitting the Ask a Question button, and you can also download the slides with hitting the icon for saving the presentation to disk. So I think we've given people enough time. Any guesses, Howard and Mark, what the breakdown will be?
Well, as I'm looking at the numbers coming back in, my thoughts would be that people had considered it, and
yeah,
there's a strong showing there. It looks like there's many who aren't familiar with it, which isn't surprising because in the world of service management, capacity management tends to be the ugly headed stepchild. So most focus on availability and problem incident management, and then of course configuration management. So this is not surprising.
Okay, great. Well, so we'll let you guys continue, and I'll join you for the Q&A at the end.
Okay. Thanks, Salvador. Well, that's great. It looks like there are several callers or companies who have at least considered ITSM as a framework for managing capacity. One major approach to achieving a holistic capacity management service model is to leverage ITIL's service management framework. ITIL takes a life cycle approach to service management, organizing governance and operational processes into divisions: strategy, design, transition, operations, and continual service improvement. ITIL service management does a great job of defining a capacity process and describing how it should work. It falls short of this documenting how to implement it. The following slides will provide some ideas on how these best practices might be achieved in the real world. As a part of service design, the enterprise-level capacity management process is comprised of three sub-processes. The first is business capacity management. This is all about understanding the business strategy, its services, and demand plans. Next is service capacity management, which focuses on services that support business capacity requirements. And finally, there's resource or component capacity management, which focuses on the specific IT resource components in relation to the services they comprise. You'll notice there's a cascading flow from business to service to resources consumed by services. And for those ITIL purists on the call, the stages that you see here are not intended to entirely mirror these sub-processes, although you can see their influence. The focus here really is to show how those sub-processes might be enabled within the context of your organization, linking your business model to your operational model, and finally providing feedback to that business model. Slide. Oh, we got to go back one, sorry. Considering that demand planning is the most critical step in determining what resource is required and how that resource is to be managed, here we ultimately want to assess business strategy, including product plans, projects, and just plain natural growth. In our retail example, this is where we'd want to understand from a business perspective what product or service changes the business has planned. Next, we'll want to translate the business plans into resource demand. So how is this accomplished? From the business planner perspective, product or service-aligned usage patterns serve as indicators of service quality and ultimately resource performance. These indicators form the demand drivers and are used as indicators of growth. For example, transaction volume. When transaction volume exceeds the business service threshold, then additional resource should be considered. But where does the threshold get set? And what specific resources align to that demand? ITIL best practices suggest using service and resource models defined in IT service management data sources, including service level management for your SLAs and OLAs, which are the operating level agreements, configuration management to align underpinning resources, and then finally setting service targets against those resources. Once assembled, you store the completed demand profile in the capacity management database. While in production, the service targets you've defined are used to monitor the services and underlying resources and provide feedback to the planners in terms of performance, consumption, volume, trend, and variation patterns from previous planning cycles. So far, we've assessed business strategy, the product service and service plans, we've talked about establishing demand drivers and their service targets. We've aligned compute resources to their demand drivers. With those paths completed, demand forecasts can now be generated. To accomplish this, we'll calculate tool-generated projections for the planning period over baseline. The business planner then adds projections for the new demand based on project plans, workload modeling, and any architectural assessments. Resource demand is then calculated and included in the capacity plan, also stored in the capacity management database. In solution design and fulfillment, we're embedding service management and organizational controls into the build and provision process, thus instituting a connection between the demand planning stage and the resources provisioned for deployment. This stage receives aggregate planning data from the business demand stage, that is, demand plans from multiple business lines and applications. Planning at this stage takes into account cascading workloads and shared provisioning models. Here I'll also point out that this stage represents a shift from what I call business-directed fulfillment. To fulfill based on service and compute requirements, where infrastructures and compute services organizations are no longer taking orders on placement strategies. More frequently, large organizations are eliminating single-use environments even at the virtual level that had previously been dictated by the funding business line. The savings in resource spend, underutilization, and data center sprawl, and the like have changed this paradigm. However, a significant driver for this change can certainly be attributed to as-a-service-based compute models, including virtualization and cloud computing. However, even with on-demand elastic provisioning models, resources are not limitless and certainly not without cost. You'll want to implement an effective fulfillment methodology that includes reuse, reallocation, and optimization strategies, leveraging standard build patterns that include monitoring and optimization tools. I believe Howard has some thoughts on how this might be accomplished. Howard?
Thanks, Mark. You know, one of the aspects that you mentioned that resonates quite well with me is the file system optimization strategy, because servers are the hubs for all company activity, and when they slow or become sluggish, crash, or require too frequent downtime, it results in a huge impact on system productivity. Server optimization really has two important overall objectives: minimizing downtime and increasing efficiency. And when you have high traffic, which is typical of most servers, this will bring about a loss of performance rather quickly when a server does suffer from some underlying issue. The problem is that system management and monitoring tools may only narrow the cause down to a range of possibilities. And one of the often overlooked situations is the amount of split IOs per second performed by the NTFS file system. Now, there are a number of technical articles in the Microsoft knowledge base that delves into the particulars of diagnosis and how to pinpoint the source of poor performance. Now, many issues of slow performance in servers such as SQL, Exchange, Lotus Notes, or just plain file print and application servers come about because of an I/O bottleneck. In fact, one of the slowest operations your system can perform is data reads and writes. Possible solutions often don't state that defragmentation of the NTFS files, because the effects of fragmentation are commonly underestimated, and especially in a virtual environment where the back-end storage may be connected to some type of a SAN array. Many tend to think of fragmentation really at a physical storage level and then ponder the value of guest-level file fragmentation or optimization and often ignore it in their virtual environments. At the guest level, the behavior of Windows and the NTFS file system is the same whether it is a physical or virtual system. In fact, NTFS doesn't even know that it's operating inside of a virtual machine. So when a user requests data to be read or written from a Windows system, the application passes an I/O request to the file system. That file system sees the disk volume, whether physical or virtual, thin or thick provisioned, as a sequential range of logical clusters. Now, each of those I/O requests takes a measurable amount of time, and the more I/Os generated by the various layers of abstraction, the longer it takes to complete a given task to read or write the data. It is true that when you combine several physical disks into a storage device, such as SAN or NAS, with RAID, you can spread the workload across multiple spindles. But all you're really doing is just masking the problem and increasing your hardware expense. Diskeeper and Velocity have technologies called IntelliWrite that helps the NTFS file system allocate a larger chunk of space such that the file, as it's being written, and subsequently preventing the vast majority of the fragmentation from occurring in the first place. And for systems that have already been in production for a while, the automatic and instant defragmentation engines will quickly clean up any pre-existing Windows file and free space fragmentation so the guest's VMs, as well as the host, are operating most efficiently. This benefit allows your backend storage to focus only on the necessary I/O traffic, and the result is access to your data is even faster and more efficient, allowing your system to handle a greater workload. This gives you the ability then to leverage standard build practices based on optimized workload rather than investing in unnecessary hardware expenses. Mark, wouldn't you agree with that?
Thanks, Howard. That makes perfect sense. Now that we've mastered optimization strategies, have deployed resources, have appropriate monitoring and management tools, our resources are now in an operational state. At stage 3, we now turn our attention to operational capacity planning and management. That is, managing what's on the floor, or in the cloud, or with the service provider. Similar to the demand planning that we did in stage 1, at the operational stage, we're really focused on capacity planning from the aggregate component or resource group level. These resources could be segmented by workload type, production versus development, or, for example, a vendor-based SAN storage pool, a logical grouping of hosts in a virtual farm, or perhaps the security of a workload might have implications on where and how it's managed. In any case, we again start with the assessment of demand, only this time we're looking at demand for resources, and more specifically, how service operational requirements translated from service level agreements, operating level agreements, are to be met and sustained. Additionally, the assessment would include newly provisioned resource from stage 2. Given the resource on the floor or in the cloud, what are the indicators or KPIs that signal the need for additional capacity? These KPIs are once again derived from availability requirements and translated to operational device-level thresholding and become the basis for the resource driver. As we did for the demand planning stage, we'll store the completed resource profile and plan in the capacity management database. So Howard, what are your thoughts on collecting capacity measurement data?
You know, enterprise capacity monitoring and analysis is really not about how much information you can collect. It's about collecting the appropriate system health indicators and the right amount of information. And certainly, without a doubt, you can capture and monitor an overwhelming amount of information from performance counters. In fact, there's more than 1,000 individual counters available to you in a Microsoft Windows environment. So you'll want to carefully choose what to monitor. Otherwise, you might collect so much information that the data will be hard to manage and difficult to decipher. Now keep in mind that more is not necessarily better with regards to capacity analysis. The process is really more about efficiency and therefore you need to tailor your capacity analysis and monitoring as accurately as possible to the server that's being configured. Every server has a common set of resources that can affect performance, reliability, stability, and availability for a given user. And for this reason, it's important that you monitor a common set of resources, namely CPU, memory, and disk I/O, to formulate your usage patterns.
Good points, Howard. This also leads to a level of predictability that is fed back into the business strategy, governance, and risk management as a part of IT service management and the enterprise capacity management lifecycle.
Exactly right, Mark. The details of system performance can be broken down into a standard baseline measurements and those that indicate a bottleneck has surfaced. When a resource is overburdened, it's just not equipped to handle higher workload capabilities. The system will experience a slowdown in performance at that point. And for any system, the slowest component of that system is, by definition, considered to be that bottleneck.
Another good point. Also, Howard, since we're on the subject of detailed monitoring, we must remember to leverage exception data as a means of predictability. For example, physical disks are also a potential trouble source. You know, they do go bad from time to time. As a result, as our retail example illustrates, big data grows the size and quantity of storage devices in modern large-scale IT installations, with thousands of storage devices making component failures the norm rather than the exception. Failure of storage can not only cause temporary data unavailability, but in the worst case, it can lead to permanent data loss. Early detection is key, where we can get in front of potential problems as a part of our overall risk management strategy. Exception avoidance practices, as illustrated in this example, need to be factored into the overall process of enterprise capacity management. With capacity subprocesses and enterprise references in place, the enterprise capacity management process is enabled for monitoring and reporting. An effective monitoring strategy will generate the necessary reports inputs that feed back into the planning process at multiple stages. It will also, over time, improve the overall efficacy and quality of your planning, providing planned versus actual comparison data. You might wonder at this point what that capacity management database is all about. What data does it contain? How is this data used? There are varying opinions on this topic, but to keep it brief, we use it to store capacity-related planning and management data to be shared across each sub-process. At a high level, it contains the business directive, who the business is, what the business wants managed, and how they want it managed. It defines the business strategy for the planning cycle and documented in the capacity plan, which also includes the forecast. Also in the CDB are service requirements. Translated from business and service management strategy, this data is focused on service performance, defining the service targets to be managed to by operational organizations and tools. The CDB also contains resource data, including the resource plans we just talked about, with their component level directives for monitoring. And finally, measurement data. This refers to performance, consumption, utilization, and exception data captured from great tools like Diskeeper and Velocity. Note that this means summary, not log-level data. Use your monitoring and management tools to collect performance samples that can later be analyzed for trend and utilization patterns, and as input to workload modeling tools. For near-time exception reporting and event automation, use these tools to correlate combinations of indicators that together form event signatures and forward alarms to your event management system. While in production, the service targets are used to monitor services and underlying resources, and provide feedback to the planners in terms of performance trend and variation patterns from previous planning cycles. This data comes from the capacity management database. So Howard, how do you think big data plays into this?
So we can now begin to see that the concept of big data isn't just the idea of how to extract and use business process information and customer buying trend habits to gain a competitive advantage. But we now see that the thousands of data points collected every second regarding system performance and health provides a hidden treasure of computer resource usage and provides insightful information that helps to lower your operating costs, increase productivity, and maximize use of systems, which then improves the system predictability and planning. The problem with big data is that all the individual data points of information is that it becomes too overwhelming to collect and manage. And performance monitoring tools simply just give too much or too little scope to help you understand and identify the problems or devise a solution before a crisis appears. So to help with this dilemma, Conducive Technologies has introduced its Diskeeper version 12. Into its product line, we've added system monitoring reporting capability, which can help identify CPU and disk I/O, including split I/O usage patterns by process executable and file type. This data will help you quickly determine what periods of the day are busiest, and if there were periods where system overhead was excessive, be able to identify that as well. This allows you to better balance workload schedules, or better yet, construct dynamic load balancing rules for virtual systems. In addition, it will let you see if there are periods where maintenance utilities could be scheduled when resources are more plentiful. Now, as Mark had mentioned, predictive drive failure is going to happen. Okay? Disk drives rarely fail all at once, but rather begin a slow deterioration process. And before being put into production, all disk drives go through some type of a burn-in process, which consists of a combination of read and write stress tests that are designed to catch many of the most common assembly and configuration type of problems. Diskeeper 12 collects environmental factors used through the self-monitoring analysis and reporting technology, SMART, which are good indicators of disk drive health. These SMART parameters, such as scan errors and reallocation counts, can have a large impact on disk failure probability. Drives typically scan the disk's surface in the background and report errors as they discover them. When you see a large scan error count, it can be related to those surface type of defects, and therefore are indicative of lower reliability. Or when the drive's logic believes that a sector is damaged, typically as the result of a reoccurring soft error, or it could even be a hard error. It can remap the faulty sector to a new physical sector drawn from the pool of spares. This reallocation count reflects the number of times this has happened, and it too can be seen as an indication of drive surface wear. When knowing about such conditions and situations, this helps reduce the loss of data and improves user productivity by allowing the data center to proactively back up and replace disks before a trouble ticket or help desk call is ever placed by the end user. I'm sure that Mark and I can go on, but I think we can sum up a few of the main points here. Mark?
Sorry, speaking on mute there. So from an enterprise capacity management perspective, my recommendations would be to adopt an enterprise lifecycle approach to capacity management, one that links business goals and objectives to your capacity planning. Business strategy and plans are the catalyst of all capacity planning. Make documented service expectations a part of the process. That's taking the business requirements and the business critical success factors in the form of KPIs and implementing them within your process and tools. Embed your business's service and availability requirements into the process as well. Once you know what that KPI is and what the business critical success factor is, use your service level articulation in order to monitor and manage against those. Even down to the device level, that's where you're setting thresholds on services and service performance, and then at the device level, you're actually setting thresholds that support those goals. Institutionalize the capacity management capability. The process handoffs, which typically have been the focus of infrastructure groups, manage them from that business tier to the service tier and then down to the actual resource level. Sharing the data along the way. And really the goal behind the capacity management database is to collect data as each of these sub-processes create information that is used in the broader, in their scope of capacity planning. Once it's in the capacity database, then it's available for all planners, and the business directive is referenceable by all levels of process, of the capacity management process. And then finally, my recommendation is to automate the process where possible. There's a lot of manual processes in place. Again, ITIL does a great job at kind of putting together that framework of why they should be connected and how they should be connected, but that doesn't really tell you how to implement it. So look at your process and automate it where possible. Howard?
Yeah, of course. And you definitely want to address opportunities to optimize the file system workload versus just throwing additional hardware into the mix. You'll want to use the concept of mining the big data with regards to system resource usage to improve your overall system planning stages, and then take proactive steps towards handling any type of disk failures. And then we would continue to use the process to develop action items and increase uptime and availability whenever possible. So those are just some of the takeaway points there and so forth. I think that at this point, Sal, were there some questions that came across or some ideas that you had?
Yeah, and before we get to the questions, I know at the start I just mentioned how conducive I think it might be new to some people, but many of the product, their technology is very familiar to most of you, I'm sure. So I just wanted to put up a slide with the suite of products. Some of these were mentioned in the presentation, but I think most people are familiar with Diskeeper. Undelete is also quite a useful tool. And what I particularly like is that you really don't need to go through lots of backups in many cases to find something and restore it. And then we've written actually a lot about velocity, and I hope I'm saying it correctly. But with the explosive growth in these virtual environments, those really need some optimizing and tuning. And the technology here is a lot of patented technology that goes into these. So still a very interesting line of products. So I just wanted to make sure folks were aware of what was available before we get into the Q&A. So with that, I'll let people continue to send in questions, but why don't we start? And maybe I guess I'll let maybe Howard, you could start with these, and Mark, if you wanted to jump in, that would be great. But why don't we start in an early slide? I think this came in around slide 10, and let me just push that out. Talked about Diskeeper and velocity. So one of the questions was, in which scenarios would I use Diskeeper, and in which would I use velocity?
Thanks, Sal. I think I'll jump in there and answer that question. It's fairly straightforward. Diskeeper would be used for your physical workstations and servers, And velocity is what's designed for the virtualized platform. It takes into consideration the work and I/O traffic across multiple guest systems, especially when talking about common SAN-type storage environments. And so velocity has some specific underlying technology there to address any concerns about disk I/O bandwidth issues.
Okay. And I guess I've been placing the wrong emphasis when I say velocity, but velocity. Right. Now, the second question here, another question is sort of dovetailing on that, and how and/or does Diskeeper work in a SAN environment?
Diskeeper works extremely well in a SAN environment, and I think, as I had mentioned earlier, sometimes people get a little too wrapped up in thinking about fragmentation and its effects at the physical storage level. And when you do have a SAN environment, the benefit that SAN provides and its increased in speed derives from its ability to scatter or disperse the workload across multiple physical disks. Whereas what Diskeeper is addressing is the fragmentation that is occurring within the NTFS file system structure, such that if we can eliminate or prevent a lot of the unnecessary I/O requests from being originated by Windows, then it has a cascading benefit that makes the SAN backend perform even better.
Next question is, does the native, this tying in with that, does the native defrag in Windows 7 mitigate the issues you've brought up here?
Not at all. The built-in defrag tool in Windows simply is not good enough for the consumer or the enterprise environment. It doesn't have the ability to prevent fragmentation from occurring, which is really one of the problems that you're trying to address, is that at the moment in time fragmentation happens, there is a performance loss and penalty. And so doing defrags after the fact really don't solve the problem when you're writing data. And as a result, Diskeeper really is the only viable solution to address this type of problem.
Okay. Another question, does fragmentation still affect virtual environments, and how?
Absolutely. In fact, it's a very good question, because when you've taken a physical server and you think either about isolated disks or direct attached type storage and so forth, now you're combining the effects of all this I/O traffic being done on these virtual platforms and funneling it in to the same common host. So disk I/O traffic is one of the top considerations one needs to take into consideration when looking at capacity planning or overall scope of performance. And so the effects of fragmentation have this massive cascading effect in dealing that you've now taken I/O traffic on one machine that now will have a direct effect on the I/O capability of other guest machines in a virtualized environment. And so it's absolutely paramount that fragmentation be addressed and handled, ideally being prevented from occurring in the first place, such that you can have more guest systems running on a virtual platform. That increases the density of the number of machines that you can have running, and ultimately it reduces your overall expenditure or cost for hardware, because you're able to leverage more virtual systems in the same physical host platform environment.
Okay. Another question, how does Diskeeper work with thin provisioned virtual machines?
Yeah, with thin provision environment, there's some technologies in Diskeeper to help prevent the data growth or sprawl of data in that thin provision type of environment. We also have technologies that allow you to reduce the size of the VHD or VMDK file based upon files that have been deleted. They can now be written with zeros such that those data blocks no longer occupy space. And when you do things such as storage vMotion or live migration, we're able to compact or trim back the amount of space that's being allocated in that thin provisioned environment.
Okay, another question here. somebody said that they're running VMware, and what do you suggest for that?
Well, in a VMware environment, our products, Velocity, are certified by VMware as something that is instrumental and very necessary and needed to optimize and contain the workload environment there. The Velocity product installs on each of the guest systems, because that's truly where an I/O request begins its journey, is an application running within the virtual machine generates an I/O request. So what better place to actually address and optimize the I/O data path is really at each of the guest level systems there.
All right. So I think we covered a little of this, but there's another question about if you could maybe talk a little bit about the difference between Diskeeper and Velocity.
Well, Diskeeper is definitely designed for the physical platform, the actual physical server or workstation. Velocity is more in tune to being able to address and handle the uniqueness of a virtualized platform, again, where you have common shared resources such as disk I/O bandwidth and the ability to detect and understand when I/O request resources on one machine may be affecting the ability of other machines to do their work. And there's specific technology in Velocity called Cognisan and VMware that allows us to understand the workload habits such that we can avoid moving any files if the workload of that environment would not sustain that type of condition without impacting the performance of other applications. So again, Velocity is designed specifically for that virtualized platform, whether it's Microsoft Hyper-V or VMware or even a Citrix Zen server type of environment. The Velocity product is designed to address those type of unique issues.
Okay, we've got another one here saying, what if my SAN is a NetApp SAN? What about fragmentation in that type of environment?
Well, even with a NetApp filer, the effects of Windows fragmentation has a negative aspect that it incurs extra I/O traffic, and by reducing that I/O traffic, you can actually make the NetApp filer perform better and more efficient. Nothing about what NetApp does on their storage side actually has any bearing on reducing the amount of fragmentation within Windows. The real concern there is when you do have these type of SAN and NAS type of storage, is that the movement of data can have an impact in terms of additional blocks or change blocks that they're tracking and so forth. And so to address that and make ourselves completely 100% compatible with NetApp and other type of SAN type storage, we rely primarily on the IntelliWrite technology within Diskeeper and Velocity to prevent that fragmentation such that no data blocks are ever having to be moved at that point, and therefore you don't run the risk of traditional defrag type of utilities incurring additional change blocks or blocks that have to be replicated and so forth that could have certainly a negative effect in terms of overall system performance.
All right. Another question here. It's a sort of a general one, but I have a large amount of data sitting on a virtual environment. Can Velocity handle this?
Absolutely. The quantity of data and so forth really is of no special concern for us because each file is looked at individually and so forth. There are unique engines associated with our products such that we're not having to analyze or look at the entire volume all at once, but can kind of segment it into smaller chunks that allows us to manipulate file information in a more expedient manner and therefore reduce any type of workload onto the system, but yet give you the full benefit of getting fragmentation or files optimized to improve the behavior of the system.
All right. Got time for another question or two here. Are there any suggestions to let me do this in English. Is there any suggestion to architect for the number of VMs and increasing density? Are there any suggestions? Okay, sorry, go ahead.
As far as any suggestions, absolutely you'll want to optimize the behavior of Windows, specifically the behavior of the file system, such that you can increase the density or the number of virtual machines you run on a given host, because the I/O traffic that's generated by each of the individual guest systems is really one of the biggest barriers when looking at how many virtual machines can you run on a given physical host. And so it's very commonly reported by our customer base that they've increased the number of guest systems on a physical host simply by optimizing the behavior of the Windows NTFS file system and eliminating and getting rid of and mostly preventing the fragmentation from occurring in the first place.
Okay. And then one thing I'd be curious about here is if we could maybe tie this back to some of the business benefits. I know we've talked about them throughout the presentation, but can we just recap some of that about, it seems like there's increased performance, but greater productivity. Can you just talk a little bit about that?
Well, I'm going to pass this back and forth between Mark and myself. Obviously, if we improve or optimize the behavior of Windows, this leads to your ability to better plan or have better plans when dealing with capacity management. Mark, what were your thoughts on that? We talked a little bit about this previously.
Well, optimization leads to better utilization of your resources, and so it can directly affect your bottom line. And not only that, in your planning process, you might be able to better serve your business demand. It was mentioned earlier that by using some of the conducive tools, you can understand where workload peaks are and where they're not, for example. So you could potentially put run two workloads in the same environment, one with demand during the day and one with high demand during the evening. So you're really able to better leverage your resources, which leads to cost savings. The other thing I think that's important is really staying in touch with what the business directive is, because if you plan from the technology stack perspective, then over time that connection between what business wants and what you're getting seems to part. So keeping a consistent cyclical repetitive revisiting of business strategy will help to keep your data center and your server plans in line with what business expectation is.
Okay. Another question is, we're jumping around a bit here. I know you talked about native defrag in Windows 7, so why would I need another solution?
Well, I think as I pointed out earlier, one of the biggest problems is that fragmentation happens, and at the moment that it is occurring, you are experiencing a performance loss right then and there. Nothing about the built-in native Windows defragmenter addresses fragmentation in a proactive way. So you're always a day late and $1 short trying to improve performance. In fact, the built-in defrag tool is disabled and turned off on servers and so forth, simply because Microsoft really is concerned about the performance impact that it might have if it were to do a defrag or a cleanup while you're trying to do a SQL query search or some other type of intensive operation. Diskeeper and Velocity, on the other hand, have no such impact on the system in terms of system resource utilization and so forth. Our product is designed to operate completely transparently in the background without incurring any additional system overhead. And so as a result, we can prevent that fragmentation from happening, which gives you right then and there the performance benefit that you would have otherwise suffered from in the absence of having our solution in place. So it's kind of equivalent to you're walking down the grocery store aisle and you drop the ketchup bottle and it splatters all over the place. Well, now you've got to walk through the muck and deal with that particular problem. If one were to prevent that ketchup bottle from breaking in the first place, you wouldn't have the mess to clean up. Okay, and that's kind of the analogy of dealing with, proactively handling fragmentation such that it doesn't cause a performance problem in the first place, and you have the added benefit you're not incurring any system resources moving the file afterwards, hoping that maybe the user will stumble across that file in the future. So we give you the benefit right up front, right here, right now, without any additional overhead. The built-in just can't do it. It's not good enough.
All right. And we have time for one more question before we wrap up. So this is a good one. I'm not sure if the person in the audience says that they're moving to virtual servers, and when their group moved, their webcast group had server failures. Whenever they did sort of authenticated webcasts, which are to individual webcast delivery to more than 1,300 people, and no root cause was found. Do you have any ideas about the source?
Well, they certainly could have me come out there as part of our professional services group and analyze their environment and give them a spot-on answer. But one of the things I'm willing to bet is they've taken their systems from physical environments and migrated into a virtualized environment. They've now combined all the I/O traffic that they were doing individually on separate servers, separate physical servers, and now all that I/O traffic is being generated and targeted or funneled through one particular host. And so the effects, I'm fairly confident that the effects of the behavior of the file system such that it became fragmented generated an exorbitant amount of I/O traffic that their underlying host system could not effectively deal with, and as a result was pushing out more I/O traffic to their back-end storage and subsequently just overburdening their back-end storage with a lot of unnecessary I/O requests. So that customer's solution could easily be buy more hardware and spread the workload out across more hardware devices or more host systems, or take a look at how can they better optimize the behavior of Windows such that they don't have that additional I/O traffic. And since this is really a software problem, a software solution is always going to be a more cost-effective type of approach.
Great. Well, we're running out of time, so I just wanted to wrap things up. First of all, thank you, Howard and Mark. Very interesting presentation, a lot of great information. So thank you both for being here. Appreciate it.
All right. Well, thanks very much, Sal. My pleasure, as always.
All right. And before you go, folks in the audience, a couple of things. One, as I mentioned earlier, you can download a copy of the presentation. Just click on the icon that saves to a folder, and you'll have that. Also, we have a short survey. If you could complete that, there's an icon with looks like a little checklist. If you can just do that on the way out, we appreciate any feedback. Now, if you want to hear any or all of this seminar again, a recorded version will be available within about a day on our eseminarslive.com website. You can play it on demand, use the same credentials you used to get in today. If you want to refer a colleague to it, they can just sign up and access it at any time. We also want to point you to, we have upcoming events on the site. You can look at eSeminars Live upcoming events for similar topics to this. And one reminder is there was a past seminar, recent one by Conducive. You can review that one there too. So I want to thank Conducive for sponsoring today's event. Again, Howard and Mark, thank you so much. Everyone that attended, thank you so much. So we appreciate your attendance. And with that, I'll sign off. This is Sal Salamone at Ziff Davis Enterprise. Thank you.
Thank you.